Welcome to Manifested Publishers.
Hello learners, welcome to Manifested online classes. We are learning chemistry from 1 and the topic is simple classification of substances. The subtopic is separation of solid liquid mixtures, and in this lesson we are going to discuss the separation of soluble solid liquid mixtures. If you remember in our previous lesson, we were discussing or we were learning the separation of insoluble solid liquid mixtures, and we used the example of sand and water, and we said that you can use two methods, and these methods were decantation and filtration. But we said that decantation is not a very effective method of separation because some solid particles, they still pass through in the process of decanting. Filtration is a method we said is very effective because all the solid particles, they are trapped by the filter paper in the process of filtering, and they are left as a residue on top of the filter paper as the water passes through the filter paper. Therefore, the water forms part of the filtrate, while the sand forms the residue. In this lesson, we are going to discuss separation of soluble solid liquid mixture, and in this case, the mixture will be a mixture of sodium chloride and water. So separation of sodium chloride and water, and we have an experiment. The aim of this experiment is a question of how can sodium chloride be separated from a mixture of sodium chloride and water. How can sodium chloride be separated from a mixture of sodium chloride and water? Sodium chloride, this is salt. Sodium chloride is salt. Therefore, when you add sodium chloride in water and stir, then sodium chloride is going to dissolve in water and you are going to form a solution. Therefore, in this case, sodium chloride is the solute, water is the solvent. Therefore, a mixture of water and sodium chloride is a solution. Therefore, sodium chloride is the solute, water is a solvent. And the mixture of these two forms a solution. And this solution, we said it's homogeneous. And homogeneous, we said, means that when the solute and the solvent particles are uniformly distributed. The solvent and the solute particles are uniformly distributed in a homogeneous solution. Therefore, the aim of this experiment is to be able to obtain sodium chloride from a mixture of sodium chloride and water. Therefore, I want to give you a procedure which you are going to use to show that. That is the procedure we are going to use in this separation. The step 1 or procedure 1, you put 20 centimeters cubed of sodium chloride solution into an evaporating basin. Second, heat the evaporating basin until crystals start forming. Remember, this evaporating basin contains a solution. A solution means the sodium chloride dissolved in water. You are heating this basin until crystals start forming. After you see the crystals start forming, then transfer this evaporating basin on a water bath and continue heating to dry the crystals. Then once the crystals are dry, then allow them to cool. So you are going to start with the evaporating basin. That is what we have. That is the first step. You have the evaporating basin. In the evaporating basin, there is sodium chloride solution. Then this evaporating basin is on a tripod stand, and you are heating this evaporating basin. We have said that you heat until crystals start forming. So the crystals, you're supposed to heat until the crystals start forming. The time you will see you started forming some solid particles, then that is now crystals. And to do this, you can use a glass rod. Glass rod will help you know whether the crystals all have started forming. Like if you dip the glass rod inside this solution as it is still being heated, and then you hold it up in the air, then you may be able to see if the crystals are ready or they have started forming, then you will be able to see some crystals on the surface of the glass rod. If you dip the glass rod inside the solution, and then you hold it up in the air, then once the crystals have started forming, then you'll be able to see some crystals of sodium chloride or this salt on the glass rod. Then at that time, you know the crystals have started forming. And what you do is you remove the evaporating basin from that direct heating, and then you put it on a water bath. Then what we mean by a water bath is this. That is what you do. Therefore, once the crystals have started forming at this point, then you are transferring the evaporating basin from the direct heating then onto a water bath. We talk about a water bath. A water bath, this is just water which is being heated. Therefore, if you heat, or what happens when you heat this water gets heated, and therefore the heat in this water is now going to evaporate the water from the solution of sodium chloride. The reason for that is to prevent, or the reason why you are heating sodium chloride solution in that way is to prevent the salt from spitting out. You know, when you heat a salt solution directly, and the crystals have started forming, then this salt may spit out of that basin, and it is dangerous because it may even get into your eyes and cause damage on your eyes. So you are heating this way to prevent the salt from spitting out in the process of evaporating. Therefore, this is what happens. And of course, the function of the wire gauze again is to ensure uniform distribution of heat. And this heat is coming from a Bunsen burner flame. Remember again, we said that the most effective flame is a non-luminous flame because of two reasons again. That one, it does not produce soot, therefore it's not going to dirtify the bottom of the beaker. And second, it is hotter when compared to the luminous flame. Therefore, this is what happens in this experiment. This method of separation is called evaporation method. It is evaporation because water, or this solution of sodium chloride, there is water and sodium chloride salt, or there's a solvent and a solute. You want, remember the aim of our experiment was to obtain sodium chloride from a mixture of sodium chloride and water. Therefore, the evaporation, that solution, when you heat that solution, then water evaporates, and at long last you'll be left with sodium chloride crystals. And that's why we say that when you transfer the evaporating basin on a water bath and continue heating to dry the crystals. Again, this transfer of the evaporating basin onto a water bath, we have said it is important to prevent the salt from spitting out in the process of evaporating. And once you have formed the crystals, then allow the crystals to cool. Then these crystals is now sodium chloride. Water has already evaporated. So you are left with sodium chloride. And that is how you are able to separate sodium chloride from a mixture of sodium chloride and water, which is a soluble, solid, liquid mixture. It is that simple. Maybe to go through to go through it again so that you understand it better. We are saying that sodium chloride is a solute, water is the solvent. And then the mixture of these two is a solution. And this is a procedure you are going through in the course of your experiment. That one, if you are given, suppose you are given 20 centimeters cubed of sodium chloride solution in an evaporating basin. So put this sodium chloride solution provided in an evaporating basin. Heat the evaporating basin until crystals start forming, like I have drawn it for you here. You are heating the evaporating basin, which is containing sodium chloride solution. So once you heat it, then you expect water will start evaporating, and you're left with sodium chloride. But once the crystals start forming, crystals, I've told you, these are just some solid particles of the salt. Once they start forming, and I've told you that you can observe whether they have started forming by dipping a glass rod into the solution and holding it up in the air. Then the point you see some crystals forming on the glass rod, then you will know that the solution has already started forming the crystals. And what you do next is to remove that solution on that direct heat and transfer it into a water bath. Then I've told you that a water bath, this is just water which is being heated. And again, the function of this water bath is ensuring slow heating or slow evaporation of sodium chloride solution. Therefore, this method is called evaporation. And I've said that the reason why you want it to or to evaporate slowly is to prevent the salt from spitting out of the evaporating basin in the course of evaporation process. And that is how we are able to separate a mixture of sodium chloride and water, or we are able to obtain sodium chloride from a mixture of sodium chloride and water. That brings us to the end of our lesson today, but before I leave, I will leave you with this assignment. And the assignment is state the method of separation which can be used to separate sodium chloride from a mixture of sodium chloride and water. Ensure that you've done that before we meet in the next lesson. And in the next lesson, we'll be discussing still the separation of soluble solid liquid mixture, but another mixture, not sodium chloride and water. Meet you in the next lesson.